starts. All right, I got three terms, an x squared, an x, and a number. This is going to factor. I'm going to put my two sets of parentheses. And I ask, okay, well, how do I get a 2x squared? Again, not a lot of options. I'll have a 2x and an x. Next thing I've got is, how do I get, I made sure that this gives me the 2x squared. Now I want to know, how do I get the 21? Oh, it's going to be 3. It's going to be 7 and 3. So I'll put a 7 and a 3. It's negative 21, so one's got to be positive, one's got to be negative. I don't know if it's right or not. I'm just creating something that I know gives me the first term and gives me the last term. The tricky part, which is where I really tried to stress a whole lot talk a whole lot yesterday, was checking to see if the middle term matches. So you do this times this, and you do this. The middle term comes from this times this, and this times this. So in my head, I'm thinking, okay, that's a negative 7x, and that's a 6x. And that gives me a negative x, which is an 11x, so I know it doesn't work. Now that's okay, right? And I switch it around, and let's see, what happens if I put the 3 here and the 7 here? I still get that negative 21, so I'm fine with that. But now when I check my middle term, see, this times this gives me negative 3x, this times this gives me a 14x, so I end up with 11x. And I've got the right number, but it's the wrong sign. And that's easy enough to fix. We just make this a minus and make that a plus. And now I get 3x minus 14x gives me the 11x, and I'm done. And to be honest, that's exactly how I factor them now. A little faster because I've done it a bit, but that's how I factor something like this. All right, now, what happens when the numbers are bigger? Well, you still kind of do the same thing. We know we're going to need to get two sets of parentheses. Now, with 16, you think, well, there's lots of ways you can get 16. You could do 16 and 1, you could do 2 and 8, you can do 4 and 4. My suggestion, always try to pick the smaller numbers when you can. Go to the bigger numbers when those don't work. So I'm going to pick 4x and 4x, because I know 4x times 4x gives me 16. Next thing I care about is the 9, and I'll do 3 and 3. And since it's a positive 9, they're both going to be the same sign. I bet it's going to be negative. So what I've just done is I've created it where I'm guaranteeing that I get the first term, I guarantee I get the last term. Now, the important part is check to see if you get the middle term matches. And you get your middle term from this and this times this, and this times this. Well, this times this gives me a negative 12x. This times this gives me another negative 12x. Oh, look, I get the negative 24x. It works, and I know it's right. Now, this is a little...
Let's go.
Okay. Question? Okay.
On our test or quiz, if we got a problem similar to that, can we just write 4x minus 3 squared?
That's what I'm about to say.
Oh.
So when there's some textbooks that actually make a big deal about something, they actually teach this problem differently than this. And to be honest, in the past I've taught it that way. Now, this is a perfectly acceptable answer. If you get here and stop, I'm fine. There's nothing wrong with it. But let's say that you have, if you were to check your answer in the back of the book, like in a textbook or an answer key, they would look at this and say, well, if you have 4x minus 3 times another 4x minus 3, they would actually write down the answer as 4x minus 3 squared. Now, if you want to write it this way, great. If you want to write it this way, that's fine too. I don't teach, when I teach factoring, I teach factoring this way. I teach it where you create two binomials that multiply to give you this. If those two binomials happen to be the same, yeah, you can write it squared, but I really don't care. I really like this idea of, that you're creating something that multiplies to give you this. That's what I want. All right, so that's kind of a recap of yesterday. Now, we're going to continue this a little bit. Actually, and then I need to talk about one type of factoring that I didn't do. It's kind of a special case, and it's probably the easier of the cases. Before I get to what I really want to talk about today. And what I really wanted to talk about today was, well, what I should have done yesterday, but I didn't. Well, let's say I give you x minus 3 times x plus 3. When I talked about multiplying, let's say I give you two binomials that are almost the same except one's a plus and one's a minus. And when you multiply them, well, let's see, we're practicing. This times this gives me x squared. This times this gives me a negative 9. As far as my middle term goes, it's this and this and this and this. So I get a minus 3x and a plus 3x, which cancel. So I just end up with x squared minus 9. Okay. Well, what if I give you x plus 5 times x minus 5? Right? Same kind of thing. They're two almost identical, right, binomials. One's a plus, one's a minus. Well, x times x is going to give me x squared. This times this gives me a negative 25. But when I look for that middle term, this times this and this times this, 5x minus 5x, it cancels, and we're just left with two terms. So most of the time you multiply two binomials, you're going to get three terms. This is one of those cases where when you multiply two binomials, you only get two terms, and they have a special name for it. And math people are not very creative. They actually call this difference of squares. Some books call it difference of two squares. Why is it called difference of squares? Well, there's a minus sign. That's where the difference comes from. Squares, x squared is a perfect square, and 25 is a perfect square. So, difference of squares. So, we're really not creative. We say, oh look, we're subtracting two squares, we'll call it difference of squares. Some books want to be a little more descriptive and say difference of two squares, but that's what it is. So why am I talking about it? Well, let's talk about when you factor. So if I give you a difference of squares, say I give you x squared minus 64. So anytime you see a difference of squares, when you factor it, your job's still the same. We still want to get those two binomials. But now your job actually is a lot easier because these things are going to be virtually identical except one's a plus and one's a minus. So we think, well, what times what gives you x squared? Let's do x and x. What times what gives you 64? That's an 8 and that's an 8. One's got to be a plus, one's got to be a minus. So when I have my difference of squares, this is what I get for a factor. All right, how do I make it harder? Well, what if I gave you 4x squared, oh, whoops. What if I give you something like 81 minus 4x squared? All right, this is still a difference of squares. This is a perfect square, 81, and this is a perfect square. Okay. So when I set it up, you don't always get to have the x at the front. Sometimes the x is at the end. So when I factor it, I want to think of what times what gives me 81. Well, that's going to give me a 9 and a 9. And then I think about what gives me a 4x squared. Well, a 2x and a 2x. And then I just need to make sure one's a plus and one's a minus. So
could you done 4x and then just x?
No, because, well, you could do that, but then when you multiply things out, you would create a middle term. The only way that you don't get a middle term when you multiply things out is if these are the same, except there's a plus and there's a minus.
Oh, a perfect square. Okay.
Yeah. Okay. So yes, technically you could have done 4x and x, but if you multiplied it out, you would have created a middle term, which is, we don't have one here. So, all right. So there's our factoring difference of squares, and I remember in algebra thinking those were the super easy ones to factor because there was no guessing involved. You just looked at it and said, okay, take the square root of this thing, take the square root of this thing, and you've got your answer. All right. So now that I've talked about this, now I can do what I want. I can present what I want to teach today. And what I want to teach today, we get some special instructions. And the special instructions are factor completely. Well, what does factor completely mean? Well, it means if you can factor, you keep factoring. So, example. Let's say that I give you 6x to the fourth minus 150x squared. Everybody write that one down. Even if you can do it in your head, I want you to write it down. Okay. Now, whenever you're given the instructions factor completely, usually it means you're going to have to go through a couple of stages of factoring. There's like, sometimes two or three different levels of factoring. And the first level of factoring is you always ask what's in common. So when I look at this, I've got two terms, and I see both terms have an x in it. And actually, in fact, I see, there's an x squared here, and there's like an x to the fourth. And since it looks like I can take out two x's from both terms, so when I ask what's in common, an x squared's in common. I also look at this and I realize that a 6 goes into both of these, so I can take a 6 out. And so if I take a 6 away from here, a 6x squared, I'm left with x squared. If I take a 6 away from the 150, like 150 divided by 6, that's going to give me 25. And when you're this is called factoring out the common factor of. And the way I always kind of think about it, I'd make sure you could do things in reverse, meaning if you distributed this, you would get this. So I get 6x squared times this gives me 6x to the fourth, 6x squared times 25 gives me 150x squared. So when you factor, the first thing you always do is you ask yourself what's in common, so I pull out what's in common. The next thing you do is you look at what you have left and you say, well, can I factor anything that I have written down? And when I look at this, I see the x squared minus 25, that's a difference of squares. So I can write this, that x squared minus 25 is going to give me an x plus 5 and an x minus 5. That 6x squared, that's still there, so I'm going to pull the 6x squared in front, and so now I factored. I have factored completely, meaning you have to keep factoring until there's nothing else you can do. So that's one example. Let's look at a slightly uglier example. So let's do 3a to the fifth minus 6 a to the fourth b, 3. I'll give you some time. Write that one down. All right. I want to factor this. Looks pretty ugly, right? Numbers aren't real nice, and you got multiple variables going around everywhere, and we don't do different powers. What you do is the first question you always ask is, what's in common? When I look at this, I see there's a 3 that goes into everything, and so I know there's a 3 in common. I also see that in each of the terms there's an a. I can't there's not a b in every term, so I see that in each of the terms there's an a. And since there's an a in all of these, I've asked myself, well, how many a's can I pull out of everybody? And if I got an a cubed, an a to the fourth, an a to the fifth, it looks like I can pull an a cubed out. And so then I'm left with a squared minus 2ab plus b squared. So, and again, it works in reverse. If you were to distribute this, 3a cubed times a squared gives me 3a to the fifth. 3a cubed times this 2ab gives me the 6a to the fourth b. 3a cubed times b squared gives me 3a cubed times b squared. So I ask myself what's in common. I pull out that common factor. Now I'm going to look at this 3-term thing, and believe it or not, this is a quadratic term, and you can factor it with 2 sets of parentheses. So I'm going to draw my two sets of parentheses. Just because you have two letters, you still approach it the exact same way. You think about this times this has got to give you a squared. The only way that's going to work is an a and an a. You think about the last term. How do you get a b squared? The only way you're going to get that is a b and a b. Now it's positive, so they're both positive or both negative. I bet they're going to be both negative because of this minus sign. And what I've just done is I've created something that gives me the first term, it gives me the last term, and I just have to make sure that the middle term matches. And so when I multiply this times this, I get negative AB. When I multiply this times this, I also get a negative AB. So minus AB minus another AB gives me minus 2AB, which is exactly what I was looking for. So, I know this factors. I just have to bring down what I had before, so I end up with 3a cubed, and now I have factored completely. All right, now your turn. What if I give you, oh, that doesn't show up very well, does it? That marker's almost done. Good. All right. Pause. This particular trinomial doesn't have anything in common. So, how do you factor something like this? Well, you put your two sets of parentheses, and you start asking. You've got to think what goes here so that this times this gives me 36x to the fourth. And I know 36 has lots of ways. There's lots of ways you can get 36, but start with the one where the numbers are close to each other. In that case, we're going to have a 6 and a 6. Also, when you see that x to the fourth, break it in half. Do like x squared times x squared. Don't do x times x cubed. That's going to make things really ugly, and it never works. So we have an x squared and we have an x squared. Again, I'm not worrying about the whole thing. I'm just worrying about, okay, what goes here that gives me my first term? And again, I'm not going to worry about the middle term at all. I'm going to worry about what gives me that last term. So what gives me the last term? Well, I've got to think what times what's going to give me 25. Well, I think 5 works. And then I think what times what gives me y to the fourth. Kind of the same logic. I'm going to have y squared. Now that's a positive number, so that means either both positive or both negative. Probably going to be both negative. And the most important part of this whole idea of factoring, see if the middle term matches. Meaning when I do this and this, and I do this and this, do I get negative 60? X squared, y squared. So when I multiply these two together, that gives me negative 30 x squared, y squared. When I multiply these two together, I also get a negative 30 x squared, y squared, which is going to give me negative 60 x squared, y squared, which is exactly what I wanted. So, what I've done is I have created something that I know when I multiply it together gives me this. All right? Now, so, yes?
Isn't that basically just like the same thing as a squared minus 2ab plus b squared with numbers?
Well, yes.
Oh, okay.
Yeah.
And then also for when you got y squared and x squared, if you multiply the, oh wait. Oh, just kidding.
Okay. So now when you look at this, right? Yeah, you could look at it and say, oh, these are exactly the same. So you could go one step further and say this is 6x squared minus 5y squared quantity squared. Right. You don't have to. My main focus is given this, right? Given some sort of trinomial, when you're factoring, I want to make sure you can write your two sets of parentheses. And you're creating something so that this times this gives you the first one, this times this gives you the last one, and then you check to see if the middle term works. All All right, so that for the most part is like your basic factoring. There's one more thing I need to talk about. And this one more thing I need to talk about is it's called sum and difference of cubes. So I'll put a little title and I'll say sum difference of cubes. Before I actually do a problem, I want to make sure we're familiar with certain numbers. You need to be familiar with things that are perfect cubes. Most of you are already familiar with things that are perfect squares. Let's talk about things that are perfect cubes. I expect everybody to know that 1 cubed is equal to 1. I don't think that's unreasonable. I also expect you to know that 2 cubed is equal to 8, 3 cubed is equal to 27.
Sum digit cubes?
What?
Does that say sum over different cubes?
Sum and difference of cubes. There's you'll see why I call it that in just a second. But so now when I'm talking about different, I want to make sure we understand values of certain cubes. So 4 cubed is 64. 5 cubes 125. And I expect everybody to know these. I expect you, when you see 125, you know that that's 5 cubed. I expect when you see 27 that you know that's 3 cubed. And when you see 64, that's 4 cubed. Those are the bare minimum. It's nice to know the rest of these. It's nice to know that 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and then 10 cubed is 1,000. We're going to be using these, right? It's like if you don't recognize that 8 is 2 cubed, we're going to have a problem, right? If you don't recognize that 216 is 6 cubed, you're not going to have a huge problem, but it's going to make your life a lot easier to know that. So I'm just making the list, right? So what is this, right? How are we going to use these? Well, so the title of this is Sum and Difference of Cubes. If I give you something like x cubed plus 8, and I say factor it, now, turns out, and we're going to find out why this works later, but it turns out that, and this is called a sum of cubes. The reason this is called a sum of cubes, it's called sum because, well, you're adding. Cubes is x cubed, is, right? So x is cubed, and that 8 is 2 cubed. So when I look at this, I see x cubed plus 2 cubed. And so if it's the reason it's called a sum of cubes is that's a cube, and we're adding. And the next example will be a difference of cubes, which will be there's a cube, and there's a minus sign. Now, as far as factoring sum of cubes go, when this factors, there's going to be a 2-part thing and a 3-part thing. And so what I'd like everybody to do, I don't care if you don't write down the title, I don't really care about that. All right, I want everyone to write down x cubed plus 8 cubed. Right? And then right below it, I want you to write that as x cubed plus 2 cubed. And we're going to sort of walk through how to factor this. Here's how we factor it. It's going to be a 2-part thing and a 3-part thing. Now, the 2-part thing is easy. You look at this and you drop the cubes. So if I look at this and I drop the cubes, I end up with x plus 2. Right? See how I looked at that and I just dropped the cubes, I got x plus 2. Once you got the 2-part thing, we're going to talk about how to get the 3-part thing. And how we get the 3-part thing is you take this first term and you square it. So x squared gives me x squared. How you get the last term is you take the second part and you square it. It's going to give me 4. How we get the middle term of our 3-part thing is we take these 2 terms and we multiply them together. Right? So, sort of recap what we did. I had a sum of cubes. I know it's going to factor as a 2-part thing and a 3-part thing. I drop the cubes for the 2-part thing. Once I get the 2-part thing, I take this and square it to get the first term. I get this and square it to get the last term. And where I get the middle term is I multiply these together. What's left are the symbols, or do I add or subtract? And how I teach this, I call it SOAP. S-O-A-P. SOAP is same, opposite.
The 4.
What?
How'd you get the 4?
Square this.
Oh, okay. And then
Take-
the 2x came
We're
from.
multiplying these two together.
Okay.
Okay? And then always positive. So, how do I interpret that? This sign is the same as this sign. This sign is opposite of this one. And the last sign is always positive. Same, opposite, always positive. All right? Let's try it again. Let's say I have x cubed minus 64. So we've got x cubed minus 64. Here's how this is going to work. It's going to factor as a 2-part thing, and it's going to factor as a 3-part thing. How we get the 2-part thing, first we have to look at this. And when you look at this, you want to recognize that you want to write it as something cubed. I've already got x cubed. Now the 64, I have to recognize that as 4 cubed. So now when I drop so I'm looking at x cubed minus 4 cubed. Now how I get my 2-part is I drop the cubes. I'm going to have x minus 4. Now there's my 2-part thing. Now to get my 3-part thing, I'm going to take this and square it. I get my first term, I take this and square it. That's going to give me x squared. I get the end, I'll take the end and square it. That's going to give me 16. And where I get my middle term is I multiply these together. So I end up with 4x. And then our last bit is
Negative 4x.
this times this.
Oh, wait.
Okay?
Yeah, sorry.
Okay. And so now let's get our symbols. And the symbols are this sign is the same, this sign is opposite, and the last is always positive. All right. I think I have time for one more. I need to make this one kind of tricky.
So for the middle sign, you said it's going to stay the same or it's going to be different?
This middle sign is always different than this one. These two signs have to be different.
Okay, thank you.
So last example. So let's say I give you 8x cubed minus 125. So I know it's going to be a 2-part thing. I know it's going to be a 3-part thing. What you want to do with this is you want to rewrite it with cubes. Think of that 8 as 2 cubed. That's x cubed. And think of that 125 as 5 cubed. Because if you can think of it this way, then drop our cubes, It's going to give us 2x minus 5. And once we get this, the 3-part thing is easy. You take this thing and square it, that's going to give us 4x squared. You take that 5 and square it to put it here, that's going to give you 25. Your middle term, you multiply these together, that's going to give us 10x. And now I need the symbols. This sign is the same, this sign's opposite, and the last is always positive. And I've got probably like a minute and a half, and so I need to do some explaining. All right, your homework tonight. You have 2. These are, one of them has got a joke where you can see the end of it. They're 9 factoring problems, just like we did yesterday. You factor it. They've got like the two binomials. You're trying to match them, and then you can answer the questions. I really don't care if you answer the bad pun at the end. The second page, so that first page I expect you to be able to do everything. The second page